Thank you, Sarvan. So he called me Mr. Ghana. So in Ghana, Mr. Ghana is actually a competition that they have, for the most muscular guy. If you are the most muscular guy, they call you Mr. Ghana. So I used to be fit, so maybe I'll get back there someday. So my product is called Swift. I'm not sure if the name has already been taken, but that's what I want to call mine now. So Swift, what we're trying to do with Swift is make sure you get there on time, or make sure you make the best decision using travel time prediction. Try to find out how many minutes it takes to get there, or how many minutes it will take to travel somewhere, right? So if you've lived in a big city like New York, this will be very will come in handy to you, especially if you move around in the city bikes. So, who are my target audience today? My target audience is, of course, city bike riders in New York City, delivery companies. So, delivery companies like Instacart, or grocery delivery companies like Instacart. What they have to do, like if you make an order online, or 5 people make an order online, they need to find out which driver. They have drivers that deliver the groceries, right? How do they determine who's the next driver that's going to take the next delivery? So they have to be able to tell how long a driver is going to take to deliver a grocery, and then be able to assign them a next task and say, okay, after you deliver this is in line for you, because we found out that it's going to take you like 10 minutes to deliver this product. ML enthusiasts, whoever wants to find out how the engine works, we can talk about that. Business owners, city dwellers like city bike drivers or bus, those who take the bus, the train. If you, like I said, if you live in New York City, one thing you want to know is you want to move, maybe you want to go 10 blocks away, you find out that sometimes riding a bike is faster than taking a taxi because you just happen to be in traffic. And how do you know that using a bike or a taxi, or using a bike or driving or a taxi is faster? Time prediction, travel time prediction. So like I always said, the problem here, one problem that Swift tries to solve is you have this city bike or bike sharing services. What happens is during the day, the bikes tend to concentrate in one part of the city. Let's say people are commuting to work and they take the bike. You see the bikes are in one part of the city, and maybe in the afternoon you have people. There's 1,000 bikes here, and there's only 2 bikes here. How do they try to manage and move bikes around? By using a travel time prediction, or the duration that a bike rental will use the bike, you can tell how many bikes are going to be at a location at a certain time, and then you can do rebalance optimization by adding that time prediction and and then forecasting. With the tool, you can tell, okay, at 4 o'clock, I'm going to have 5 bikes here because of this number of people that have the bikes, and they're going to get there at this time. And together with my demand, I know, okay, it's not going to be enough bikes. I'm going to send a truck to go and rebalance the bikes at the location. And then, of course, if you have an accurate prediction of how long your bike trips or travel time is going to take, you can sleep more and say, okay, if I leave at exactly 9:02, I know I'm going to get there on time because this is what the prediction told me. And then, like I said, resource management with the company like Instacart. How do you determine the next driver they are going to give the groceries to deliver based on their travel time? And so what Swift tries to do, it employs analysis of historical data to uncover like patterns and trends with past travel times. So in other words, it's you can say, why wouldn't you use Google Maps or whatever, but this is specific to a specific domain. So Google Maps will probably have the data for everyone in the city, or drivers and everyone. But so if you have something like bike sharing, you have the particular pattern or trends of those bike users, and then you can actually have an accurate prediction of the time travel. And it's adaptive as well. As data gets added on, it will change depending on the pattern and trends that bikers have. So let's say if it happens that maybe now 60-year-olds are taking more time, or maybe women are driving faster than riding faster than women, it's gonna actually reflect in the app, in the prediction. And then, like I said, it's different that it uses it's not just like Google. Well, I'm not sure how Google maps works, but this one uses the user behavior, the time of the day, as well as the age and the gender, and the time of the day of the week. And then it uses the model engine is XGBoost. XGBoost is a gradient boosting choose algorithm, kind of like random forest. It combines weaker models to create an accurate prediction. So what are the key elements of a Swift, or how does it work? So it's very simple. You put information like your origin, destination, and if you do want to put in your gender and birth year, that's fine. I have a more accurate prediction. But basically, all you need is just to put in your origin, destination, and then with that, what it'll do is the information, it hits an API, and then the API will generate it'll hit a reference table. The reference table will get the coordinates of where you're trying to go, and then with that, it will generate the time of the day, time of the week, the month. It'll get your user information, your age, as well as your gender and what group you fall in, and then with that, it will generate a travel time prediction for you. Like I said, it uses XGBoost, and if you want to talk about XGBoost, we can discuss that later. But it's an ensemble algorithm, kind of like random forest, just that it differs from random forest, that it runs the trees one at a time, and it tries to correct the errors from the previous tree, whereas random forest does the random sampling. So the timeline. Well, I have one of the gotchas here was I underestimated the project that I wanted to do. In the beginning, I had this whole big idea of using Kafka and all kinds of stuff, and I had this huge plan. I actually even sent it to Shavan. I sent him like a whole diagram of using Kafka and streaming, and actually, so the data I got came from CityBike, and they have two types of data. They have historical data, and they have streaming data as well. So I wanted to combine the two and see if I can provide more information about the city bikes, because that's why I based my my model on. But yeah, like I said, I underestimated the time. Thanksgiving was there. I've spent time with family, so I came out with the minimum viable product. It still works. So week one, I built the user interface, and I did some exploratory data analysis. And then there weren't in the EDA, there weren't any all stuff around. Of course, the few things that I found were that you can find a bike trip that will take 5,000 seconds, and with those, when you go and dig out, you find out these are bikes that were taken out for servicing. Or sometimes you see a bike trip that's like 90 seconds. Where does someone go 90 seconds? And I actually went to New York. I wanted to try it out. Okay, it's like what might happen is sometimes you take a bike, you realize, okay, I don't really need the bike, and you just put it back. And so with the EDA, those type of information, you want to take it out, because those will just give you wrong predictions. And then after that, I did some feature engineering, like age group, time of the day, the month, and all these were binned. The month wasn't like March or February. I binned the month into like seasons. And then I ran the model. I ran 3 models. I ran linear regression, so because it's a regression problem. I ran random sample, and then the XGBoost. I was gonna go with random sample, but I remember Shravan said this in class, but I probably must have missed it. But I learned the hard way that when you train a random model, it actually stores the trees in the pickle file itself. So what I came up with was a 10 gig pickle file, and I was like, oh yeah, I remember Shravan said that in class. So yeah, so I didn't go with the random forest. I went with the XGBoost, which actually performed better in terms of RMS SLE. And then week 3, I deployed the model as a REST API. So I'll just explain the process flow. It's very straightforward. You just have the historical data that I got from CityBike's website. Then I trained the model, deployed it as a REST API, and then what happens is I have a user interface. The user interface interacts with the API. The API has to get the coordinates of the location. So if you're going from A to B, you can't put that in the model. So you have to get the actual latitude and longitude, and then generate the distance. So here's the reference data, and then gives that back to the API, and then it gets you get your travel time. So that's it. That's it. I'm good. I'm just gonna demo it. I had some technical issues because the demo gods are on my side. I have my UI ready, but I was having issues with it showing. So I'll just do it in Postman for those of you who are familiar with that. But I can actually show you how my UI look like. This is it's not actually my work, like he said. I took someone's work and I made it mine. His name is Manir on YouTube. He had a nice React UI. I'm not a React guy, but at least I was able to. He said I was able to reverse engineer what he did, and then so I had what I wanted to do was like you put in your location, destination, and then you get the trip distance. But as you can see, it's not working. But I can demo that. I have technical difficulties. I can demo that in using Postman. So if you can see here, this is my API. It has a two parameter start and end. If you want to put in your gender and date of birth, you can do that as well as optional. But if you put that in, it'll generate 7 minutes. I can try another location as well, just so you can see how it works.
These are New York.
Yeah, these are New York locations, yeah, because the training was done with New York data. So this is going from 8th Avenue to University Place and 8th Street, East 8th Street. And then this one is 10 minutes. If you actually know these locations, you know that these predictions are close to right because the other location was 8th Avenue, but a few blocks away, and it was 7 minutes. So if you also want to see, I actually have the data was trained on 2017 city bike data, and I actually did some prediction on 2018 data, and it was like very, very close. Some of them were just a few seconds away. If you want to see that, I'll be available. I have the data set, and I can show you.
So that's docking station to docking station?
Yeah, docking station to docking station, yeah. And then that's it. That's all I have for today.
So,
You guys have any?
how does it correlate with Google timing?
That's a good question. Yeah, I said I was going to do that, but
there is a bike and see how it.
yeah, I can. That's one thing I'll consider, and then in the future as well, add the streaming data with Kafka. And then what I'll do is with the UI, once you put a start and destination, I also tell you how many bikes are available at that location because you can get that information with the streaming data. So that's something that I can consider. And then this because it's an API, you can implement it in so many. It's a very simple model. By changing a few features, you can actually use in other domains as well. Like I said, with Instacart or if you want to use it by yourself, just to you actually give it your own training data, and it will tell you how long you take to get a certain place. You don't have to be a business. You could just be an individual and use the API. Yeah. Any questions?
I remember you also talked about air taxi, water taxi, city bikes. Is this a model that can be applied to?
Yeah. So this model, it's like I said, it's very generic. You can apply to anywhere where travel time prediction it comes in handy. And like one thing I also said is that you live in New York City, right? You want to move, you want to travel, or you want to go a few blocks away. You will find out that in New York sometimes it's actually faster to walk or faster to take a bike than driving or taking a taxi. So if you have an app, let's say you have an app, a third-party app, that you put in your start location, end location, and then they can compare, the three modes of travel. Say, okay, if I go with a taxi, train, or bike, which one is faster? And then it will tell you, and you can say, okay, if I take a bike or if I walk, it's faster than taking a taxi because of all the traffic in New York City. Yeah.
And why did you go to SageMaker?
Oh yeah, so I actually went to SageMaker because the data I had is 60 million records. I trained on 60 million. I remember I was talking to Sravan, and Sravan was like, just sample it. He actually even sent me a link, the CSV something. I forgot what it's called, but it's CSV module in Python. He said, okay, just because Pandas actually processes data in memory a lot, so he says use that module and then sample your data. And I was stubborn. I was like, no, I want to use all 16 gigabytes of my training model. So I ended up crashing my laptop and Sravan's laptop, and then we were like, you know what? Let's just go to the cloud. So yeah, we went to Amazon SageMaker, and it helped a lot because I don't have to worry about buying hardware resources or anything like that. And actually, it's easy to spin up. It took less than, you can ask any of the guys, it took less than 5 minutes to spin up a cluster, to spin up a SageMaker notebook. It's very, I mean, you can beef it up with as much resources as Amazon will allow to train your model and then shut it down in if the model takes, I realized that in I realized that in XGBoost, if you use the D matrix data type, which XGBoost likes or uses, you can actually cut down your training time. If I had used that, maybe because it took 4 hours to train my model, maybe I could have had 2 hours to train the model. And the downside is I had to pay some money because I think it was like 70 cents to train your model per hour. So
70 cents?
yeah.
But it only took 4 hours?
Yeah, 4 hours.
That's
Yeah,
less,
yeah,
that's
I mean,
less than a Starbucks.
I know, and then you don't have to go and buy memory. I actually run on 64 GB memory, so that's like
What language did you interface with SageMaker with?
Python. So SageMaker is just like a Jupyter notebook. Yeah.
So you said that by doing this, you get to sleep well?
Yeah.
I do not know if that helped or not. Getting that extra resource.
Oh yeah, definitely. Well, especially me.
Oh, you
I mean,
slept
had
well.
some. Yeah, no. Now I'm gonna sleep well. Yes, because that's.
Craig has a question.
Yeah.
So is this time is the live status like if I query now or in the midnight that will be the same number?
So the difference is that the data is not being fed new information. So if it was the model was like being fed and was being retrained, let's say if I retrain it every day, then it will be kind of more than. But right now, the data is based off of all of last year, which is 60 million records. 16 gigabytes, 60 million records and 3 gigabytes of data. Yeah, that's what it is.
Festus, thank you.